Along with the law of cosines, the law of sines is one of the most awesome tools for working with angles and sides of triangles. And one of the great things about the law of sines, just like the law of cosines, is that it does not have to be used in a right triangle. So as you're aware, like SOHCAHTOA using sine, cosine, tangent really only works in right triangles, but the law of sines and the law of cosines both are usable in all triangles. I'll point out here that due to the structure of the law of sines, it's most useful for triangles that exhibit ASA or SSA properties. Now you may remember from geometry that SSA was kind of a bad one, and what that really yields is it yields something called the ambiguous case of the law of sines. I'm not going to get into that in this video. So the red note down below says the law of sines can be complicated when it's used to find the angle in an SSA triangle. So basically, for this video, I'm not going to cover that. I'm going to cover that in a later one. In this one, I'm just going to talk about the basic use of the law of sines. So the way the law of sines works is, imagine that you've got, a triangle here that has an angle A and side A across from it, an angle B and side B across from it, and an angle C with side C across from it. The idea is that any one of these ratios will be equal to one another. So if you take the ratio of A to the sine of A, it'll be the same as B to the sine of B, and that'll be the same as C to the sine of C. Now in practice, when we do this, you're always going to pick two ratios and set them equal to one another. So you might pick these two, or you might pick these two, or you might pick the first and the third. The short of it is basically if you pick any two angle side pairs, the ratio of the side to the sine of the angle will be the same, and that is the law of sines. So I have an example for us to look at here. Find the values of x and y in the triangle below. So we might first attempt to find x, right? So when we're looking at x, we're sort of looking at, well, there's the angle of 20 on the side of x, and then we want to pick one other pair. So, we could pick y and this, but that's troublesome because I don't know what this angle is. It's not hard to find. And I also don't know what y is, and I don't want to have two variables. So I'm going to look at x and 20, and then I'm also going to look at 5 and 60. So the setup for the law of sines is we're supposed to put x over the sine of 20 degrees, and this is supposed to be equal to 5 over the sine of 60 degrees. Okay. If I multiply the sine 20 over, we'll get x equals 5 sine 20 over the sine of 60 degrees. And if we plug that into the calculator, we'll find out that this is going to give us 1.975. So that's the value of x. Okay. It's worth taking a moment to think about whether that answer makes sense. Like I really feel like in trig and in pretty much all the math we do, we want to pay attention to whether things make sense. So across from the 60-degree angle was 5. Across from 20-degree angle, which is smaller, we get x, which is about 2. That seems reasonable. At this point, I'd like you to pause the video and you guys go through and find angle y, or not angle y, but side y, using the law of sines. So the first thing we're going to need is we're going to need this angle up here. Because these two add up to 80, this will have to be 100 degrees up here. So we will have y over 100 degrees equals, now you have two choices here. You could use the x and 20 pair, or you could use the 5 and 60 pair. My recommendation is always going to be to go with the one that was given to you. That way if you made a mistake here, you don't end up making a mistake here as well. So I'm going to go with 5 and the sine of 60 again. So just like we did last time, oops, sorry, this should have been the sine of 100 degrees here. So y equals 5 times the sine of 100 degrees over the sine of 60 degrees. And that gives us 5.686. Again, we take a moment to make sure that answer makes sense. 5.686 is the largest side, compared to the 1.975 and the 5. This is the largest one, and it's across from 100 degrees, which is the largest angle. Now, some people will start to worry, like, whoa, wait a minute, 100 degrees is almost twice as big as 60 is. Why isn't this twice as big as 5? It's actually interesting. The law of sines is why that's not true. The law of sines doesn't say that A is proportional to A and that B is proportional to B. It says that A is proportional to the sine of A, B is proportional to the sine of B. And so you're not going to find that when you double an angle, you're going to double the associated side. The larger angles will get larger sides, but they will not just be directly proportional to one another. Okay, so that's the law of sines.